Welcome to this webinar where we're going to be looking at our latest product iteration, which you can see behind me, which is our Gateway Plus, which is bringing the capability to pick up medium voltage faults out in your network. A little bit of housekeeping before I start. If you're looking for this in German, my colleagues have already recorded this, so you can find that either on the media section of our website or on our YouTube channel. This is primarily aimed at our international audience. Before I go into the first part of this presentation, I'm going to first of all give you a bit of an introduction to SMIGHT. If you know who we are and what we do, feel free to skip over that part of the video and straight on to the main content. If you're new to us, it's a good idea just to understand where we come from, what we do before watching the rest of this video. Just a little bit of background of us as a company. Now, we're between 60 to 70 people, and we're coming from the fields of understanding how networks work, but also understanding how IoT technology. We bring those two things together to create the kind of expertise that we need to deliver the kind of products which we do. We already work with over 150 network operators, primarily in Germany, but also in 6 other European countries, where we're helping them to understand what's happening in their low voltage grids. We have about 6,000 substations already fitted out, and that equates to something like 45,000 feeders, which are being measured across all 4 phases every minute, every day. What we're always trying to get across with this information is not, aren't we bidding great? It's more about that our solution is being used at scale by a multitude of different network operators. It's proven, it's scalable, it's something that you can definitely rely on. One final point on this slide is that we as a company are ISO 27001 certified, so you can be sure that the way we develop and the way we run our systems is run in a secure fashion. Now let's look at our current offering, where all the pieces fit together. This is the way we like to look at it, called like 3 main pillars of our offering with a foundation of system operation. Just going to run through each of these. This will be important when we look at the rest of the new Gateway Plus later on in the video. So first of all, we have our data capture layer. So essentially, we as a company offer our customers a series of different sensors and a gateway to be able to capture data about the low voltage grid. So these could be installed in substations or in distribution cabinets. It can be installed at the transformer level or at the feeder level. And essentially what we're capturing is current and voltage data. That's what you need to know to be able to understand what the power flows are in your grid. So all of these have been designed with the ease of installation in mind. So they're quick and easy to get out into the field without any complex processes. It was really important to us from day one to make sure that the data that we're capturing can be used straight away. We don't want it just sitting in a server somewhere doing nothing. So that's where our analyze pillar comes from. Here we have 3 pieces. We have our cockpit. This is essentially a visualization tool to be able to interpret the data straight away. So as a network operator, you can come in from an overview level of how's my grid doing in general, to then hone in on the points where you have critical situations and be able to pull apart the data and understand in more detail what's going on. On top of that, we have various reporting. We have our monthly reports, which are automatically generated. So you have something more for management to see a summary of what's happened in the past month. And then we also run grid checkups where we go into much more detail. We pull apart the data in different ways to then understand what's going on in the network over a larger time period, aggregating all the data together. And then finally, we have our API, which enables the data that's being captured to be able to be communicated out into other systems. So it's obviously very important that the data is not trapped, as it were, in our system. It's available to all the other systems that you might be using. That could be a grid planning tool, a state estimation tool, or a digital twin. Those systems live off data, and therefore making sure the data you're capturing with SMIGHT is available to have the API for that system integration. Now, what we see as a kind of natural progression is that we're capturing data, you're getting understanding through the analysis. This naturally leads on to control, which is the final pillar I have here. And this is where, if you've got an issue out in the grid, yes, you can deal with it with reinforcement, but it's becoming more and more a topic of you can deal with those issues through flexibility. And so we see our platform as being a key component in that landscape of being how do you know where, when, and to what extent do you activate flexibility. So what our system can do is work out where you have issues and send out signals to whatever the provider may be to either dim down whether it's solar feed-in or loads on the network to then keep everything stable. So that's our control piece. And finally, across the bottom here, we have our system operation layer. This is representing the fact that we run all of this as a complete system. So we're looking after all the devices that are out there, all the data communication, all the data storage, all the data security, but we also support the installation process with an application. So all of that is provided as part of an overall solution. So you get everything that you see here. When you work with SMIGHT, you get devices which are easy to install, you get software to be able to make sure you can use the data, and you get applications to be able to, for instance, control the grid. And all of this is supported as a plug-and-play solution. So that's us as an overall solution. As I say, we're focused on the low-voltage grid and collecting this data. Let's move on to what we're looking at today. And this is on the topic of medium voltage faults. So let's first of all try and understand where some network operators are today. So a medium voltage fault can happen out there. It could be a tree falling on a line. It could be a digger digging through a cable or something else. These things happen. At the moment, a lot of network operators will have fault passage indicators, which will indicate in the actual substation where the fault has occurred. So they're saying there are devices out there that can detect this, but generally these are offline. So the control room can see there has been a fault. So they'll see, okay, this medium voltage ring has seen a fault. So the whole thing's gone down. They know that much information, but they don't know where in the ring that fault has happened. And so what then happens is you have a very manual process to go out and check from station to station where the fault has actually occurred. So you go out to the first station, you look at the fault passage indicator, it will say, okay, upstream, downstream, left or right of this substation is where the fault is. Close that one up, drive to the next station, look in there, that will tell you also it's in this direction. You keep going until you find the station that points back in the direction you came from. Then you know it's between those 2 points in the network. And from that point, you can then isolate the fault and re-energize the network and get the power back onto the users. The difficulty here is that process is quite long. So if you're very lucky, it might be in the first part of the network. If you're very unlucky, it may be at the last point that you're checking, depending on how it goes. But any which way, because it's a very manual process, it's a very lengthy process. And because from the medium network, you have a lot of users at the low voltage level, the leverage effect of a lot of time with lots of users has quite a high impact on the SAIDI or SAIDI, depending on how you pronounce it, key metric for the network operators. And so being able to address these more quickly is really important. And one final point is then also the earth faults. So earth faults can happen. And the first earth fault isn't actually all that critical, but it represents a danger because as soon as the second earth fault occurs, that's particularly dangerous. And so being able to know that the first one has happened and where it might be is also very important for safety. So that's the kind of situation where we're at the moment. What does SMIGHT want to do? What we want to do is offer a solution to be able to get those fault indicator readings into our cloud so that we can get that data into your SCADA system quickly and effectively. And so what we've created with our new Gateway Plus is the ability to read out the Modbus RTU connection so you can make a connection to those fault passage indicators. And so with that brings a new methodology. So until now, our gateway has worked on a schedule. So it sends out its data according to a schedule. Now it will be an event-based transmission so that when the event happens, it immediately sends the signal out so you get to know about it as soon as possible. It's an important change to the architecture. And also with this, we're bringing support for the IEC 104 protocol. So obviously, when a fault like this happens, the data or the information about that fault needs to land in the control room. The way to communicate with the control room is the 104 protocol. So it's not necessarily that the gateway can speak the 104 protocol, but our cloud can, and therefore this is a new development, goes hand in hand with the Gateway Plus. So really what we're trying to do is go from searching to knowing. This is how we kind of view this as kind of real-time fault finding at the medium voltage level as a new development. So let's look at this as a kind of system architecture level. What I've got up on the screen here at the moment is how our system currently works. So we have our gateways which speak via Bluetooth to our sensors. The sensors, as you can see on the screen here, are all the low voltage side, so whether it's at the transformer level or at the feeder level. And we have the LTE, so the public mobile network connection up into the cloud, and then the API to get the data out. That's what I've described before. And what's coming new with the Gateway Plus are these pieces. So the first piece is these fault passage indicators. So I've just been speaking about. They're on the medium voltage side of the transformer. They're talking via Modbus RTU. It could also be either one of the digital analog inputs. Could also be the case if it's a relay-based fault passage indicator. Those can also be connected. With this, we gain the capability of being able to read out other transformer monitors. So right now we have a cooperation with Yanetsa. We have a Bluetooth dongle which can be inserted in the back of the power analyzer. That's obviously limited to a particular number of devices, but lots of other transformer monitors are already out there in the market and are most likely able to speak Modbus RTU. So we're bringing the capability to read out a multitude of other transformer monitors. With the digital and analog inputs, also bringing the capability of reading a door contact sensor or a temperature sensor. These are also things that have been requested. With the Gateway Plus, it's going to have all of the old capabilities from our standard gateway, also bringing in the ability to read out all of these other devices which you would typically find in a substation. Another little piece that's turned up here on the diagram is the optional 450 megahertz piece on the communication between the gateway and the cloud. I'm going to go into this in a little bit more detail, but just to touch on this, this is essentially a private network for the utilities in Germany. I think in some other countries are also implementing this band as well, so that in the case of a power outage, you have a network that's still operational because it's buffered with batteries. And the final piece, it's not related directly to the Gateway Plus, but to this application, is the IEC 104 protocol to make sure that those fault conditions are being sent into the SCADA system. It's not that you want them on the kind of our front end. That's not where they belong. They belong in the SCADA system. That's why we have the 104 protocol support being added as well. Let's have a little look here at the comparison between our standard gateway and the Gateway Plus. There's a number of differences. You can pause the video here and look at the thing. I'll just highlight one or 2 points here. One is the power supply. So with our standard gateway, you get 230 volts AC. With the Plus gateway, we have the addition of having the option of 24 volt DC supply. And the reasons that that's there is that in most substations, there'll be a backup power supply. So that in the case of a fault, when the substation no longer has power itself coming from the grid, it has power to be able to run the devices, such as the gateway in this case. And so we have the 24 volt DC connection on there. Lots of the other aspects are either the same or they're the new features, which you can see here. But it's important to note the power supply aspect. Now let's look at the compatibility. So when this launches, which is in the summer of 2026, we've got the devices highlighted in yellow. This table will be the first devices that are going to be supported, and the other ones will come soon after. And so if you have those already, we can get going straight away this summer. But if you've got the other devices, they'll be coming soon. If you have a different fault passage indicator supplier, if you could write into the comments under this video or send us a message, that will be very useful for us to gauge which types are being used by which network operators and gauge our kind of rollout plan for other supported devices. That would be very helpful. So I said before, I'd quickly mention a bit more on the 450 megahertz. What's this all about and how does it work? So again, what it's there for is it's a private network that's dedicated to utilities, and it's there for in the case of a blackout of some variety or some kind of emergency. How we're implementing it is every single gateway will come with a 450 megahertz SIM card in it. It won't be activated, but it'll be ready to be activated. So we will support you as a network operator to get that process in place, whether it's directly with a contract or using the contract you may already have and getting all of those SIM cards provisioned and up and running. It's important to bear in mind that as soon as you have that active, that comes with an additional cost. And then if you actually send data over those networks, that will also have a cost. So on a normal operation, the gateways will use the normal public networks because that's very inexpensive. And then in the case of an outage, they'll then use the 450 megahertz, which will incur a cost, but it's only in an outage situation. So in comparison to the value that you're getting, it's very important. The key thing for us is that we'll support you through that process with the provisioning and getting those devices up and running. Okay. The next piece here is the data transmission paths. So what I got up on the screen is kind of like our standard flow of data. So our devices into the gateways, up into the cloud, all those features that comes with that on the operational level are all described there. It's things like the fact that our system can easily be installed in a plug and play manner. We provide all of the IoT infrastructure, all of the support. And then we have the onward communication that happens from the cloud, whether it's the API that I described before, or our front end, or our reporting, that's all there. That's part of the solution. That's there, whichever type of gateway you use. And then the new piece is what we're calling the control room connector. That's the 104 protocol. I want to look at that in a little bit more detail. So first of all, what information is going to be transmitted by the 104 protocol? So first and foremost, it's about events. So that's the short circuits, the earth faults, or contact events, but it can also be things like transient faults if they're being picked up as well. We can also transmit the measured values. So at the medium voltage level, we can measure the current, the voltage, frequency, and other kind of key parameters. You can get those and you can take that directly up into your SCADA system. And then just to mention also the onboarding process. Now, each network operator runs a different SCADA system that's configured in a different way, so we can't offer a standardized installation process or setup process for this. Therefore, it has to be individual. So when you want to implement this, we need to sit down with you and work out how your system operates, what documentation you have in place, what experience you or your provider have with such an integration, and that's going to affect how long and how much energy it's going to take from our side to be able to do that. So we're going to quote individually for making that integration. So in the German version of this webinar, we had a bunch of live questions come in. I thought I'd take those as a FAQ section just to give you, I imagine that those questions may be in people's minds watching this. So the first question that we got is whether the 450 megahertz is automatically active and whether it entails any extra costs. So I touched on this, but just to reiterate, it's always ready, but it's not active. So to get it active, we need to work out whether you already have a contract or whether we contract it on your behalf. That does entail additional costs, like a baseline layer of costs to have the service there ready. And then there's additional costs if any data goes over the network, but that will only happen from our side if there's actually an outage and we have to use the network. And the next question was, what measurements and fault types are captured at the medium voltage level? So from a measurement point of view, we've got our current and voltage, power, reactive power, the phase angle, frequency. We've got kind of a basic set of the data that you need to know at that level. And in terms of fault types, as I think I mentioned before, we've got short circuits, earth faults, and transient faults, which are being picked up. And then the next question was, how long does the control room connection onboarding process take? And this is one of those, how long is a piece of string? It depends a little bit on the setup that you have, the level of documentation, whether you've done anything similar to this in the past. If you have done, and it's well documented, it's quite a quick and easy process, but if this is the first time, there's a certain learning process that we need to go through. So we'll work it out with you. We'll get it all absolutely clear before we start, that you know what you're getting yourself into. Next question was, what's the difference between a typical RTU and the Gateway Plus? So this was quite a perceptive question. So an RTU stands for a remote terminal unit. This is the typical way that such medium voltage devices would be actually connected to the control room. Now there's kind of two differentiating factors. One is that the RTUs can receive a signal and carry out actions, whereas our Gateway Plus can't. So the direction of the communication is different. Ours is one way, the data is coming out. With an RTU, the data can come in and actions can take place. And the other thing to consider is the level of complexity. What we're trying to implement is something that's much simpler, but also much lower cost and easier to implement. So where you have these fault passage indicators, it may not be worth a full automation project to implement a full RTU system. We're saying you can bring those online in a much simpler fashion rather than going for a full RTU automation project. The next question was, how can I see the Modbus data in the SMIGHT IQ cockpit? So depends what you mean by the data. So something like a fault event, that won't be shown in the cockpit. That's not the right place for it. It's due to seeing in the SCADA system. What you will be able to see is the same kind of values that we might take out from any other device. So at the moment, for instance, we'll pick out total harmonic distortion from the Anitza device. We could do exactly the same if you have a power quality analyzer that we're connecting to. We can bring that data up. So any data that you can see at the moment within SMIGHT IQ cockpits, you'd be able to also see in the future. We're not adding anything in with the new system. Then we had a question about the power supply. So whether the 230 volt AC and the 34 volt DC can be simultaneously connected. They can be simultaneously connected, but then the device will choose which it uses. It will use the 230 volt automatically, and only when that drops away will it switch over to the 24 volt DC. The next question was, is this connection of the fault passage indicators only possible with the Gateway Plus? Is it not something that's coming as an update to our standard gateways? So the short answer is yes, it's only possible through the Gateway Plus. That's how we've arranged it at the moment. We think the question probably came from the direction noting that the Anitza power analyzer we currently integrate with our Bluetooth dongle, that can also connect to the fault passage indicator. So you could imagine a kind of like a bridging system where the information is passed from one device to the other and then up into the cloud. That may be technically possible. We haven't looked into that yet. We might do that in the future, but right now, if you want to be able to connect these devices, the Gateway Plus is the only way to do it. And the final question was, do the fault passage indicators count towards the 20 sensors that the gateway can handle? So in our spec sheet that you would have seen before, we state that our gateway can connect to 20 sensors. What we're referring to those is Bluetooth sensors. So that's our feeder sensors for current. It could be our voltage sensor. It could be the Bluetooth dongle for the Anitza devices. That's what we're counting in 20. These other inputs are coming through a direct wired connection to the gateway, and they don't count towards that 20. So you can have up to 20 Bluetooth connected sensors, and then additionally, you can have the fault passage indicators or any other Modbus RTU connection. So how can I test all of this? The way that we tend to work with our customers is we offer this pilot program where you can pick out how many stations you want to equip. You get to test us basically from start to finish. What's it like trying to install the SMIGHT devices? What does the data look like? What's the customer service like? And also what's the kind of data reporting like? So you get to kind of really test the full spectrum of what we offer in a low risk environment. So if you don't like it or something goes wrong, you can easily send the devices back and at least you've got the data. If you do like it and do want to carry on using it, the money that you spent is credited against the devices in the future. This is how we like to introduce ourselves to customers. You get a chance to test us and work with us and see whether what we promised we can actually deliver. And so I'd really encourage anyone who finds any of the aspects that they've seen today in this video interesting is to get in contact. Let's set up a pilot. That's the best way of really getting in contact with what we do, is to be able to test this and see for yourself. So that leaves me just to round off with, if you liked this or any of the other content you can find on our media section of our website. If you want to stay up to date, you've either got our newsletter, which you've got a link here to sign up to, or on our LinkedIn page, we keep regular updates, other content like this. We also post on our YouTube channel. If you want to get into contact, we have our sales@smight.com email address where we'll be able to help you. So thank you very much for your attention, and I'll see you in the next video.